So section 8.1 is titled Systems of Linear Equations, Substitution and Elimination. Not that you couldn't read that. And essentially every problem in section 8.1 is going to have either 2 or 3 equations. And if there's 2 equations and 2 unknowns, each of the equations will graph to be a line. And we're essentially finding where the lines intersect. The first 6 problems, there's really not any algebra to do. They give me a system of linear equations. A system means more than one set of equations. They're linear because none of the letters have exponents. And a solution to a system of linear equations is a value for x and y, or possibly x, y, and z if there's 3 unknowns, that satisfies both equations. Problems 1 through 6, the instructions say verify the given values are solutions to the systems of equations. Simply to do this, I'm going to go to the top equation and let x equal to 4 and y equal to 2, and make sure that that's a true equation. If I can plug into the top equation 4 for x and 2 for y and get a true statement, that means the point 4, 2 is a solution to the top equation. And it's going to work because when I do the math here, the 4 times 4 for the 4x is 16, and the minus 3 times 2 for the minus 3y is going to be minus 6. That's going to give me 10 equal to 10. So 4, 2 is a solution to the top equation. For it to be a solution to the system of equations, it also has to be a solution to the bottom equation. So I'm going to do the same thing in the bottom equation. Namely, I'm going to plug in 4 for x and 2 for y and make sure I get a true statement. When I plug in 4 for x, I'm left with 2 times 4, which is 8. When I plug in 2 for y, I'm left with just a plus 2. And this gives me 10 equal to 10. This is everything I need to do for problem 1. What I could do is show you graphically what's going on. So graphically, what's going on is this point 4, 2 is the intersection of these 2 lines. So if I wanted to, I could graph 4x minus 3y equal to 10 and 2x plus y equal to 10, and the point where that's a solution to the system of equations is going to be the intersection point. This point right here is going to be the point where the graphs intersect. This is going to take a few minutes to do. If you don't care to watch this, you can fast forward to the next group of problems if you care to. So let me graph both of these on my calculator. And to graph both of these, I need to solve them for y. So I'm going to do some algebra to solve the left equation, or the top equation, for y. First, I'm going to add 3y to both sides. That's going to make 4x equals 3y plus 10. Then I'm going to minus 10 from both sides. The reason I added 3y is I like the positive y. This gives me 4x minus 10 equals to 3y. And then I'm going to divide everything by 3. So divide by 3, divide by 3, divide by 3. And that's going to give me 4 thirds x, or 4x over 3, minus 10 thirds equal to y. On my calculator in y1, I'm going to enter 4 thirds x minus 10 thirds, and that will have the same graph as the equation 4x minus 3y equals to 10. This equation, I was supposed to write 2x plus y equals to 10. And when I solve it for y, I'm going to enter that solved equation into y2. To solve this for y, it just takes one step. I'm going to get y equals minus 2x plus 10. And in y2, I'm going to enter minus 2x plus 10. So each one of these equations can be graphed, and because the answer to this system of equations is 4, 2, they're going to intersect at the point y2. So let me hit y equals and graph in y1, parentheses 4 divided by 3, x minus 10 divided by 3, and then in y2 do negative 2x plus 10, and then do zoom standard. I'm graphing these equations, and you'll see what happens when I graph them. So I'll go zoom standard. Each equation is going to graph to be a line. The first graph is the line of the top equation. The second graph is the bottom equation. And I claim they intersect at the point 4,2. That should be the point 4,2. Very easy to get the intersection point on my calculator. To get the intersection point on my calculator of 4,2, I just hit second, and then the trace key. I go down to option 5 that says intersect. I hit enter, and then I get my cursor as close as I can to the point where the two lines cross, and then I can just hit enter quickly 3 times, and it will do everything it needs to do. There's more technical things I can do, but just now hitting enter once, twice, and then 3 times, it's going to tell me that those two lines intersect at the point 4,2. So for each problem in section 8.1, I'm finding where equations intersect, essentially. So for problem 1, there's no graphing to do. You just have to verify that 3, 1 is a solution to the system by plugging 3 for x and 1 for y into both equations. And both times you do that, you have to get a true statement. 3 and 4 are rather ugly. To verify that 5, 7 is a solution to the system of equations in number 4, into the top equation, I'm going to plug in 5 for x and go 4/5 times 5 minus, and then 7 for y, minus 3/7 times 7 equals to 1. I can do this by hand, but a lot of students don't like to do fraction work by hand. So let me do this work on my calculator. I'm going to go 4 divided by 5 in a parentheses, and then another parentheses for the times 5, and then minus 3 divided by 7 in a parentheses, and then another parentheses with a times 7. And when I hit enter, I better get 1. For 5, 7 to be a solution to the system, when I plug it in the top equation, the left side has to become 1 because the right side is already 1, which it is. I have my calculator in 3 decimal mode. Let me get it out of that mode by hitting the mode button and going down to float, and then second and quit. Now it makes if I hit enter again, it makes the 1 into a 1. So it's a solution to the top equation. For those of you that wanted to do it by hand, these things could have been canceled. These 5s and these 7s could have been canceled. When you're multiplying an integer by a fraction, you could cancel the integer with that denominator. And if I would have canceled out the 5s in the first piece, I would have been left with a 4. The 7s in the second, I would have been left with a minus 3, and that would have given me the 1 manually. So 5, 7 is a solution to the top equation. Now I'll go down to the bottom equation to make sure it works there too. In the bottom equation, I'm going to plug in 5 for that x and 7 for that y, and make sure it simplifies to be 17 because the right side is 17, which it does. So I know that 5, 7 is a solution to that system of equations, which means if I took the time to solve this equation for y and that equation for y and graph these, that these two lines are going to intersect at the point 5, 7. So number 3 is your goal, so pause the video and do it. In problem 6, this is hard for me to do visually. This would be a 3-dimensional graph. It's not actually a line, it's actually essentially a sheet of paper that goes forever in every direction. And even without knowing what the graph is, this is a system of 3 equations and 3 unknowns. And these letters will go in alphabetical order. The 2 will stand for the x part of the solution, the 4 will stand for the y, the 1 will stand for the z. For 2, 4, 1 to be a solution to this system, I need to be able to plug it into the top equation, the middle equation, and the bottom equation, and I need to get 3 true statements. So if I can plug 2, 4, 1 into each equation, 2 for x, 4 for y, and 1 for z, and if I get 3 true statements, then that point, that ordered triple, is a solution to the system of equations. If it works in 1 or 2 but not all of them, then it's not a solution to the system of equations. To be a solution to the system, for each of the 3 equations, if you plug 2 for x, 4 for y, and 1 for z, you need to get 3 true statements. So I set up what I needed to do. In the top equation, I plugged in 2 for x, 4 for y, and 1 for z. I did it in the middle and the bottom, and now I'm just going to simplify. For the top equation here, I get 4 minus 4 plus 2 equal to 2. And then these 4's cancel each other out. So I'm left with 2 equal to 2. So 2, 4, 1 is the solution to the top equation. The bottom one the middle one, I get 6 minus 4 plus 1. And the 6 minus 4 comes out to be 2. And then 2 plus 1 is 3. So 2, 4, 1 is also a solution to the second system because it gives a true statement. And in the bottom one, this just comes out to 2 plus 4 plus 1 when I change that x to 2, that y to 4, and that z to 1. And that comes out to 7 equal to 7. So I've done perfectly, and I'm just going to jump into the next group of problems, and we'll learn how to solve these using the substitution method. And then sometimes these problems that they have no solutions, I have lots of solutions. I'll talk about those when it comes up. So problems 7 and 8, or 7 through 20, the instructions say solve the system of equations using the substitution method. And then it makes a comment saying if the system has no solutions, say that it's inconsistent. And if it has infinitely many solutions, write your answer in this fancy form. The second and third sentence, I will get to those, explaining those as it's needed, but right now it's not needed. First, we need to learn how to solve a system of equations using the substitution method. The substitution method involves solving one of the equations for one of the letters and substituting it in the other equation. So to do the substitution method, you need to pick an equation. Could be the top equation or the bottom equation. And solve that equation for a letter. If it's not already done. So that's going to be the first thing, and the first step's going to be done in the first problem at least. And then second, I'm going to substitute into the other equation and solve. And then third, I need to solve for the other letter. So for this problem 8, my answer for number 8 is going to be a value for x and a value for y where these 2 points intersect. So my answer for number 8, I'm expecting it to be inside of parentheses a number that represents the x coordinate of where the 2 lines intersect, and then a number that represents the y coordinate where the 2 lines intersect. For my first step, I'm going to pick an equation and solve it for the letter of my choice. I'm going to pick the top equation and solve it for x because that's already done. So that's my first step. And usually there's work to do here. But because the top equation was already solved for x, that was going to be my choice. When you start number 7, you're going to pick the top equation and solve it for y because that's already done. There's no extra algebra to do. So that was my first step for number 8. My second step is to substitute into the other equation. So what I'm going to do is change the x in the bottom equation to 2y minus 3. So I'm substituting what x is equal to into the other equation. The other equation is the bottom equation. When I substitute, I need a parentheses. So I'm going to make this 4 times 2y minus 3 plus y equals to 5 and solve. I'm going to solve this and get 8y minus 12 plus, I'm going to emphasize that this is really 1y equals to 5. Now I'm going to add the 8y and 1y and get 9y. So this gives me 9y minus 12 equals to 5. Now I'm going to add 12 to both sides to start to finish up the and solve. This will give me 9y equals 17. And I get a really unpleasant fraction answer for the y part of my answer. So the y is going to be 17 over 9. So as I go to write my answer down, I'm going to write in the y coordinate 17 over 9. Done with the second step. The second step was doing the substituting into the other equation and solving. Third is solve for the other letter. When I go to solve for the other letter, I can choose any equation that has that letter. When I go to do my step 3 in this problem, to solve for the other letter is the x, I'm going to use x equals 2y minus 3. And I'm going to plug in 17 over 9 for y. So I'm going to go 2 times 17 over 9 minus 3 equals to y. And I have no desire to do that by hand. So I'll pull out my calculator and go 2 parentheses 17 divided by 9 minus 3, math, enter, enter, and I get x is 7 over 9. That bothers me because I don't often give fraction answers. So I'm going to check to see if I'm right. I'm done, but I probably could add a step 4. It's optional, but never a bad idea to check. And usually when I check, I'm going to check on my calculator and not show so much work. So for checking, I need to go into the top equation, plug 7/9 in for x, and 17 over 9 in for y, and make sure both sides simplify to be the same number. Well, when I do the checking in the top equation, the left-hand side 7/9, so the right-hand side needs to come out to 7/9. So on my calculator, I'm going to do that right-hand side. I'm going to go 2 parentheses 17 divided by 9 parentheses minus 3, and then math, enter, enter, and I get 7 over 9 when I plug that number of 17 over 9 into the top equation. So the top equation works because I get 7/9 equals 7/9 when I plug it in. The bottom equation, I'm going to go and try to check it by plugging 7 over 9 in for x and 17 over 9 in for y. And when I do that checking, the left-hand side has to simplify to be 5 because the right-hand side is already 5. So again, on my calculator, I'm going to check. For my checking here, I'm going to go 4 parentheses 7 divided by 9 plus 17 divided by 9, and then I get 5, which is perfect. So I've checked my answer. I know I'm completely correct. So give number 7 a go. And I'll move on to the next page and try to do number 10. So my first step in number 10 is to pick an equation and solve it for the letter of my choice. This is the substitution method. There's another method that we'll eventually learn that doesn't involve this first step. It has a different first step. For my first step, I'm going to take the bottom equation and solve for y because I'm not going to get fractions when I do that. So to solve the bottom equation for y, I would just minus 2x from both sides from the bottom equation and get y equals minus 2x plus 5. Step 2 is to substitute, that's why it's called the substitution method, into the other equation and solve. So step 1, pick an equation and a letter and solve it for the letter of my choice. 2, substitute into the other equation. So what I'm going to do in my step 2 is in the other equation, which is the top equation, I'm going to change that y to negative 2x plus 5. So I'm going to rewrite that top equation as 4x minus 3 times negative 2x plus 5 equal to 5. So I just changed that y to that, left everything else the same, and I'm going to solve this now. So I'm going to get 4x, and then minus 3 times minus 2x is plus 6x, minus 3 times positive 5 is minus 15, and then equals to 5. I'm going to add the 4x and the 6x and get 10x. That gives me 10x minus 15 is 5. I'm going to add 15 to both sides. That will give me 10x equals to 20. And then I'll divide by 10. So done with step 2, I've got an answer for x, which is going to be x equal to 2. 3 is to solve for the other letter. And you can use any equation that has that letter. I'm going to use this equation. So now I'm going to solve for y, which is my other letter. I'm going to use y equals minus 2x plus 5. But I'm going to plug in 2 for x. So I'll get y equals to negative 2 times 2 plus 5. That's going to be negative 4 plus 5, which is positive 1. For number 10, my answer is going to be the point x equal to 2, y equal to 1. Takes a lot of time to check. I'll check this one, but I'm not going to check every one, otherwise it's going to take too long. So for 4, it's optional, it's checking. So into the top equation, which is 4x minus 3y equal to 5, I'm going to plug in 2 for x and 1 for y, and make sure I get a true statement. This gives me 8 minus 3 equals to 5, which is 5 equal to 5, so that checks. And into the bottom equation, which is 2x plus y equal to 5, I'm also going to plug in 2 for x and 1 for y. That's going to give me 4 plus 1 equal to 5, which simplifies to 5 equal to 5. So every solution is checkable. If you don't make a math error, you're not going to get extraneous solutions, meaning solutions that don't check. So give number 9 a go. I'll flash up 11 and 12, and they're a little bit harder. So step 1 in number 12 is to pick an equation and solve it for a letter. I'm definitely not going to solve a letter, pick the top equation to do any algebra with, because that's a disaster. So I'm going to take the bottom equation. I can solve it for x or I can solve it for y. I'm going to solve for my step 1, the bottom for y, specifically because the y doesn't have a number in front of it. So my first step is always to pick an equation and solve it for a letter. So my bottom equation was 2x minus y equal to 8. I want that y to be positive. If I multiply, well heck, I'm going to say add y to both sides to get the y positive. I could have multiplied by negative 1 to do that. Adding y to both sides would give me 2x equals to y plus 8. And then I can just minus 8 from both sides. So step 1 accomplished. That's just about exactly what you should do for your step 1. Done with step 1. Step 2, I'm going to substitute into the other equation. Now, I'm going to write or a simplified version of the other equation. Because that other equation is a disaster. To substitute into this equation, it's not fun. So in this other equation, I'm going to make a simplified version of it. And the simplified version of it is going to be what I get when I clear the fractions. And I can clear the fractions by multiplying every fraction by 10. Or if I want to, I can write 10 over 1. So multiplying every fraction and the number 3 by 10 is going to create a simplified version of the other equation that I can substitute my y equal to 2x minus 8 in. I wrote 10 over 1 just to help you see the canceling. The first canceling, I'm going to cancel the 10 and the 5. The 5's going to go away, turn into a 1. The 10's going to be a 2. And now I'm going to multiply 2 times 2 times x. 2 times 2 is 4, and I have the x left over. Second canceling, I'm going to cancel the 10 with the 2. The 2's going to go away, the fraction will be gone, the 10 will turn into a 5, and I'll multiply 5 times 1 times y and get plus 5y, and then 10 times 3 is 30. So this is what I'm going to substitute in. So for my step 3, I'm going to take this y equal to 2x minus 8, and plug it in for that y as opposed to using the top equation, the original top equation, and I'll still get the same answer. So I'm going to take that equation in my step 2, I guess, of 5x plus 4x plus 5y equal to 30, and I'm going to change the y to 2x minus 8. So I'm going to get 4x plus 5 times 2x minus 8 equals 30. That's just changing that y to 2x minus 8, and now I need to solve. I'm going to clear the parentheses and get 4x plus 10x minus 40 equals to 30. I'm going to add the 4x plus 10x and get 14x minus 40 equals to 30. Then I'm going to add 40 to both sides and get 14x equals to 70. And then I'm going to divide both sides by 14. And 70 over 14 at least reduces by 2. It might even reduce a lot. So 70 divided by 14 equals, oh, it comes out to be 5. That's beautiful. So this gives me x equal to 5. Done with the second step. Now I need to solve for the other letter. And to solve for the other letter, I'm going to use this equation. So now I'm going to solve for y, which is the other letter. And I'm going to use y equal to 2x minus 8. I'm going to plug in 5 for x and get y equals to 2 times 5 minus 8. That's going to give me y equals 10 minus 8, which is y equal to 2. So for number 12, my answer is going to be x equal to 5, y equal to 2. I certainly can check that. I kind of checked it in my head and it works, but it's a nuisance to check every one of these things, and the time it takes to do these videos I already know is really kind of ridiculous. So I'll skip the checking on that one and let you make a stab at number 11. Just to save you a little grief, let me do 13 with you. You can pause the video and do 13, but I'll do 13 instead of 14 should I say. Probably for my first step, I'm going to solve the bottom equation for x. So as I do number 13 as opposed to number 14, it's probably easiest to solve the bottom equation for x. I definitely wouldn't want to work with that top equation. That's a ridiculous equation. And in the bottom equation, it just takes one step to solve for x. It's probably the easiest letter to solve for. So I'm going to get x equal to y minus 2 when I do that. And before moving on to my second step, I'm going to modify the top equation to clear the fractions. I'll do this off to the side again. So I'm going to modify the top equation. The top equation has these horrible fractions that I really don't want to contend with. I'm going to multiply everything by 15 to clear the fractions. And if it helps, I'm going to write 15 over 1 where I already have a fraction and go into my canceling mode. First canceling, the 15 cancels with the 3 and becomes a 5. Then I'm going to multiply 5 times 4x and get 20x. Second canceling, 15 cancels with the 5 and becomes a 3. The fraction goes away because the 5 cancels. I multiply 3 times 1y and get plus a 3y. And then 5 times 15, which I didn't need to write the 15 as a fraction because the 5 wasn't a fraction, gives me 75. This is what I'm going to substitute in. So I'm going to take this equation and substitute it into the better version of the bottom equation. So real specifically, I'm going to change that x to y minus 2 and go 20 times y minus 2 plus 3y equals to 75. Clear the parentheses, get 20 times y, which is 20y. 20 times minus 2 gives me a minus 40 plus 3y equals to 75. Add the 20y plus 3y and get 23y minus 40 equals 75. Now I'm going to add 40 to both sides. On the left-hand side, I'll be left with my 23y. On the right-hand side, I can do that without my calculator. Those add up to 115. And now I'm going to divide both sides by 23. I think that comes out to 5 when I do 115 divided by 23, but I'll try on my calculator. So 115 divided by 23 gives me a 5. So that's part of my answer. Part of my answer is y equal to 5. I need to solve now for the other letter. The other letter is x. To solve for x, I'm going to use the equation x equal to y minus 2. And I'm going to plug in 5 for x, or 5 for y. I'll get x equal to 5 minus 2, which will give me x equal to 3. The answer to number 13 is x equal to 3, y equal to 5. I'm done with this, but you certainly can check. If I wanted to check, I should check into the original problem. So if I wanted to check, I can plug into the top equation 3 for x, and into the bottom equation 5 for y, and make sure I get a true statement. Let me just do that on my calculator, even though it's not that hard to do in my head. So if I was checking this, I'd go 4 divided by 3, parentheses 3 for the 4/3 times 3, and then plus, and then parentheses 1 divided by 5 times 5 in parentheses. And when I hit equals, I should get 5, which I do. So the left-hand side simplified to be 5, which was equal to the right-hand side. So 3, 5 works in the top equation. And then I'd go to the bottom equation. I'd plug a 3 in for that x. That minus sign will stay there. A 5 in for that y. And I don't need my calculator to know that that left-hand side reduces to minus 2. But it does. All right. We're about to, I think, head into something that was referred to in the problems, in the instructions. It says if the system has no solution, say that it's inconsistent. So for the first 3 or 4 or 5 problems that we've done, we've found where the two equations of the lines intersect. Let me show you graphically what happens in problem 16. So I'm going to show you the graphical interpretation to number 16. To do a graphical answer, I have to solve each equation for y. So I'm going to take the top equation and solve it for y. I'm going to get the y to be positive and add 3y to both sides. You don't have to do this, but I'm just trying to help you understand what's going to happen, what our algebra is telling us once we get into the algebra. This is not actually the way to solve this problem, but it's going to, I think it'll help. So I'm solving the top equation for y, and I get x over 3 minus 7 over 3 equals to y. And in y1, I'm going to enter x over 3 minus 7 over 3 and graph it. Let me just get that done real quickly. So in y1, clear out the stuff that I put in. Go x divided by 3 minus 7 divided by 3. Graphs to be that. And do the same for the next line and try to find where the lines intersect. So the next line is 5x minus 15y equals to 9. I don't like the y being negative, so to solve this for y so I could graph it on my calculator, I'm going to add 15y to both sides and get 5x equals 15y plus 9. Then I'm going to minus 9 from both sides and get 5x minus 9 equals 15y. And then I'm going to divide everything by 15. And I'll get some reduction. The fraction here reduces by 5, and I get 1/3 x. The fraction here reduces by 3. I get minus 3/5 equals to y. And I'm going to enter that in my y2. In my y2, I'm going to enter 1/3 x minus 3/5. This one right here is really 1/3 x minus 7/3, because that x can be moved to the off to the side. Both of these lines have the same slope, so they're going to be parallel. When I go now in y2 and graph parentheses 1 divided by 3x minus 3 divided by 5 and graph it, you'll see that the graphs are completely parallel and they never cross. This is called an inconsistent system of equations. The graphs, I'm trying to find out where the graphs intersect. These lines are parallel, so they never intersect. That means there's no solution. So my answer to problem 16, when I get into the algebra, is going to be there's no solution. And a fancier way to say that there's no solution is to say that these are inconsistent, this system of equations. I don't almost ever use the word inconsistent. I usually say there's no solution. Algebraically, what I'm going to what's going to happen is when I have a no solution or I have parallel lines, both letters will drop out and you'll be left with a false statement. So anytime you're doing this work, if both letters drop out and a false statement is left, like 6 equal to 9 or 2 equal to 3, the letters drop out and a false statement remains, you're done doing algebra and there's no solution. So as soon as the letters drop out, I stop doing my algebra. And you write no solution. Or you can write inconsistent. It's going to happen for your problem 15 as well as my problem 16. Both of these are inconsistent, or both of these would graph to be parallel lines, so there's no solutions. So let me do all this on another sheet of paper for problem 16, because I've kind of wasted this whole sheet of paper. So for 16, the initial system of equations was x minus 3y equal to 7 and 5x minus 15y equals to 9. My step 1 is I'm going to pick an equation and solve it for a letter. For step 1, I'm going to solve the top equation for x. Easy enough to do. I'm just going to add 3y to both sides. That's why I left a little room here so I didn't have to write that again. And that's going to give me x equals 3y plus 7. Now I'm going to substitute into the bottom equation. So real specifically, for the x in the bottom equation, I'm going to change it to 3y plus 7. And I'm going to go 5 times 3y plus 7 minus 15y equals to 9. I'm going to clear the parentheses and get 15y plus 35 by multiplying 5 times 3y to get the 15y, 5 times 7 to get the 35. I still have the minus 15y. I still have the equals 9. And now the y's are going to cancel, and you're going to be left with just a 35 on the left-hand side and a 9 on the right-hand side. As soon as the letters drop out, if there's a false statement that remains, you're finished doing your algebra. You just simply write no solution. I've started doing my algebra. All the letters dropped out. I have a false statement that 35 doesn't equal to 9. So my answer to problem 16 is just no solution. Or you could use the more mathematically elegant word and say that this is an inconsistent system of equations. So your problem 15 should be the same. '17 and 18 are the other thing that was written up front. So the first few problems, we solved each system using the substitution method. We got one solution because the lines intersected in one place. The last problem, we solved a system of equations that had no solutions because the lines were parallel lines. I said there's no solutions, but we could have said it's inconsistent. I don't even know if I spelled inconsistent right. The last thing that can happen, we haven't got to yet, if the system has infinitely many solutions, write your answer in this form. Generally, for these kinds of problems, I don't do the no solutions or infinitely many solution problems on the test. So just the first few problems where there was one solution, one single point where the lines intersected is really what we have to worry about. But I need to show you this just in case you get it in another class. So as I move on to number 18, let me do it the graphing way. So I'm going to solve 18 by graphing just to show you what happens. So I'm going to take the top equation and solve it for y and put it in my y1. Super easy to solve this one for y. I'm going to minus 6x from both sides and get 2y equals minus 6x plus 3. And then I'm going to divide everything by 2 and get y equals negative 3x plus 3 halves. And I'm going to graph that in y1. Generally, I would never ever do these by graphing, but just because I want to illustrate something that to help you understand why the algebra is doing what it's doing is the only reason I'm graphing these. So I'm entering in y1 that negative 3x plus 3 halves, cleared out my last graphs, and it just graphs to be just a nice line. Move on to the bottom equation and do the same thing. The bottom equation is 12x plus 4y equals to 15. I'm going to solve this for y. I'm going to minus 12x from both sides. And that's going to give me 4y equals minus 12x plus 15. And then I'm going to divide everything by 4. On the left-hand side, I'm going to get y. On the right-hand side, negative 12 divided by 4 gives me a negative 3x. And the fraction 15 over 4 doesn't reduce. Oh, I'll be darned. Really? I wonder if I made a mistake. I guess I didn't make a mistake. This is also going to be another inconsistent system. I just wasted a bunch of time, but that's okay. Let me graph this. Negative 3x plus 15 divided by 4. Really? Times 3 times 2. Oh, yeah. Now when I graph it, I get another set of parallel lines, and so this is also going to be a no solution. I thought this was going to be the case where there's infinitely many solutions, but I was wrong. My answer to problem 18, because these graphed to be parallel lines, is supposed to be no solution or inconsistent. All right, so algebraically, I'm going to take the top equation and solve it for y. So step 1, I need to pick an equation and solve it for a letter. For me, solving the top for y is probably the best step. To solve the top for y, I have to divide by 2, and 6 divided by 2 is not a fraction, but 3 divided by 2 is a fraction. I like to not get fractions when I'm solving for a letter. I can't avoid that here, but it has smaller numbers, the top equation, so I picked it. If I solve for x, I have to divide by 6, and that's going to actually give me more fractions. So solving the top equation for y, I think I already did that. You get 2y equals negative 6x plus 3. And then when I divide by 2, I get that. Y equals negative 3x plus 3 halves. And now I'm going to substitute into the bottom equation. So second part of this is substituting. So in for the bottom equation, and for that y, I'm going to plug that. I might have to use my calculator here for a second. So this is going to give me 12x plus 4 times minus 3x plus 3 halves equal to 15. That's just changing that y and leaving the rest of that equation the same. Now I'm going to clear that parentheses. I'm going to leave the 12x in the, well, I'm not going to actually have a plus sign because now I'm going to get 4 times minus 3x. I'm going to write 12x minus 12x. Next, I'm going to do 4 times 3 halves on my calculator. So 4 parentheses 3 divided by 2, and I get 6. So this is going to give me 12x, and then that's a minus 12x. That multiplication gives me a plus 6. The 12x's cancel, so the letters cancel. And after the letters cancel, I have a false statement. If the letters cancel and I get a false statement, I write no solution. Again, you can write the word inconsistent if that somehow just seems more appealing than writing no solution. I don't generally put inconsistence or no solutions on the test, so give 17 a go. And let me walk through number 19. 19, I believe, is the problem that has infinitely many solutions. And let me just try to walk through it real quickly with you. So I'll skip 20 and move on to 19. Let me do 19 graphically. And this is just to help your understanding of what's going on, more so than the algebra that's necessary. So to do it graphically, I need to take each equation and solve them for y. Top equation, I'm going to solve for y by minusing 4x from both sides. That's going to give me 2y equals minus 4x plus 6. And then I'll divide by 2 and get y equals negative 2x plus 3. And into my y1, I'm going to enter minus 2x plus 3. That's going to be the graph of the top equation. So for problem number 19, I'm going to graph y equals negative 2x plus 3 to represent the top equation. Just a simple line. I'll move on and do the bottom equation. The bottom equation is 12x plus 6y equals 18. I'm going to minus 12x from both sides. That's going to give me 6y equals minus 12x plus 18. And then I'll divide by 6, divide by 6, divide by 6. That's going to give me y equals minus 2x plus 3. And that's what I'm going to enter in y2. So I'm going to graph in y2 the second equation, minus 2x plus 3. That looks exactly like the first equation, so I'm not going to see a distinct graph. These two equations, they started off looking different, but when you solve them for y, they look the same. If I would have left them the same and didn't solve them for y and graph by hands, the graphs still would overlap. When the graphs coincide, there's infinitely many solutions. So when the graphs coincide, meaning they're essentially the same graph, every point on the graph is a solution. And we say that there are infinitely many solutions. And we write our answer fancy. We write our answer in this form. It's a set of xy such that y equals mx plus b, where x is any real number. So we write it like this. The answer is the set of xy such that y equals whatever it equals to, where x is any real number. For this particular problem, I can't just write no solution for an answer. I have to write this fancy answer. And you'll notice if I took the top equation and solved it for y, or the bottom equation and solved it for y, I'd get the same thing. The answer to problem 19, which again you're not going to be responsible for on a test, the proper way to write an answer when the lines coincide would be using set builder notation, which say the solution is any point x comma y that's on the line y equals negative 2x plus 3, where x is any real number. This is a redo of this video, and I got into a ridiculously long explanation on this, and it was kind of a waste of time. I don't test on it, nor is it super important. You might see this in linear algebra, but not probably anytime sooner. Maybe even in Math 218. But I'll just leave it at that and won't discuss that solution like I did last time. It was kind of ridiculous. So I'm going to do 19 by hand, and I can tell that the lines are going to coincide if the letters cancel and you're left with a true statement. So for problem 19, because I know ahead of time that there's going to be infinitely many solutions, or the graphs of the lines coincide, I should make a comment. So if, when you're doing the algebra, both letters drop out, and you are left with a true statement as opposed to a false statement. Then there are infinitely many solutions. Let me get to that point with this problem 19 and then show you how to get the solution written. So for problem 19, my step 1 is going to be to pick an equation and solve it for a letter. I'm going to solve the top for y. If I solved the top for x, I'd have to divide by 4 and I'd get fractions. So solving the top for y, I get 4x plus 2y equal to 6. I minus 4x from both sides. That gives me 2y equals minus 4x plus 6. Then I divide by 2, divide by 2, divide by 2. This gives me y equals minus 2x plus 3. I'm going to now, for my step 2, I'm going to substitute this into the bottom equation. So the bottom equation had a 12x, it had a 6y. Now I'm going to change that y to minus 2x plus 3. And I'm going to solve it. Soon as the letters drop out, I'm done with my algebra. So this is going to give me 12x minus 12x, multiplying 6 times minus 2x, plus 18, multiplying the 6 by 3, equals to 18. The 12x's cancel. I have 18 on the left side and 18 on the right side. That means the lines coincide. If you graphed them, they're the same graph. So there's infinitely many solutions. To write your solution properly, so the step 3 of this, to write my solution, because there's infinitely many solutions, if you haven't already, solve an equation, pick an equation and solve it for y. I have, so this is done. But if you would have picked an equation and solved for x, you'll need to do this. So I pick an equation and solve for y, and insert in this template the set of x, y such that y equals mx plus b for all real numbers x. So what I'm going to do is just going to insert this into there, and we'll just say that's the proper way to write it and be done with that. It's not going to be on the test, and again, my videos are so insanely long. If I say everything that I want to say, they even get longer. So I'm just going to stop it here and say the proper way to write the solution if all the letters drop out is using the template. And the template is given to you in the homework. Well, other than I started changing these words up a little bit. But those words are flexible. So that would be the answer, or the best answer I could write for number 19, other than instead of saying for all real numbers x, I could say where x is any real number after the set of x, y such that y equals whatever y equals to, comma, and then some words where it says x is any real number. All right, so that's probably a good enough stopping point to call this a part 1. And we'll move on and do the elimination method in a part 2. And then a part 3 will have 3 letters and 3 unknowns.